to write using one variable. Figure out what you're working in terms of. It says the base of a parallelogram is 3 times its height. All right, we're learning what the base is in terms of the height because it's comparing it to the height. So we're going to just use the height as our variable. So the height will be h, and then we have to tell what the base is in terms of the height. What is it compared to the height? It's 3 times the height. So the base will be 3h. And if you do that to start with, you won't have any but trouble writing this equation and figuring it out. It says the base of a parallelogram. So we know the area of a parallelogram is equal to the base times the height. And we're just going to put in 3h for the base because that's what it tells the base is equal to. And then put in h for the height. Okay? And we know that the area is 108. So we take out the area of the parallelogram and we put in 108 square inches. Now you can even write in square inches if you want to, which is nice because it winds up working out. You can see how the units will turn into what they are. Okay, so h times h is h squared. So we get 3h squared is equal to 108 inches squared. That looks like meters. Divide by 3 on both sides. 108 divided by 3 is 36 inches squared. And then we're going to do, oops, this is h squared. I got it. Okay, sorry. H squared. And then we're going to take the square root of both sides, and we get h is equal to 36 inches. And that's where our square disappears because we took the square root of inches squared. So the height is 36. Then what is the base? The base is 3 times the height, or 3 times 36. Oops, I forgot to take the square root, so it's 6. Sorry. I said it, and I took the square root of the units, but I did not take the square root of the height. That's okay. Okay, so if the height is 6, then the base is going to be 3 times that, or 18. And then you can work it out and see if it works. 6 times 18 would have to be equal to 108, and it is. So you can check it. All right, quadrilaterals A, B, C, D, and E, F, G, H are similar. The perimeter of ABCD is 40 inches, and the perimeter of EFGH is 16 inches. Now you know that the perimeters are going to be proportional to the sides and any other segments that we have, and then you square that to find the ratio of the areas. So it says find the ratios of the perimeters of ABCD to EFGH. So you start with the ABCD, which is 40 inches. And you can either write that like this, 40 to 16. Well, you know what? This can be reduced. We can divide both of these by 4. What else can we divide by? That will give us 10 and 4. So we can divide by 8. Okay, and when we divide both of them by 8, we get 5 to 2. Or you could have written them like a fraction, 40 to 16 equals 5 to 2. All right, now it says, find the ratio of the corresponding side lengths of ABCD to EFGH. And on your theorem list, it should state that the side lengths are in the same ratio for similar figures as the perimeters are, or any other length segment. So that's going to be 5 to 2 as well. Then it says, find the ratio of the areas. To find the ratio of the areas, you need to square the ratio of the perimeter or the side length, and we get 25 to 4. Distribute that square to both of them. Now, if you had started with the ratio of the areas, and this might happen to you, if you had started with the ratio of the areas, and let's say it was, let's see, 162 was the ratio to 8. The first thing you would want to do is put that in lowest terms. Okay, well you can see those are weird numbers. You can see that those are both divisible by 2. So you would say, okay, 81 to 4 is the ratio of the areas. Now, if we square the perimeter, the ratio of the perimeter or the side lengths to get the area, to go backwards from the ratio of the area to get the perimeter or the side lengths, you take the square root and you get 9 to 2. No, that's not equal. I'm sorry. It would be the new ratio. Okay, this is the ratio of side length. They're definitely not equal. If I put a square root sign over there, I could say that. Okay, remember to reduce it first when you're going that direction, because if you reduce it, you can see where the square is, but if you can't, when you take the square root, it's just going to be annoying. So always reduce it first. Okay, find the indicated